Welcome back to TECHMIMIC, where you can simply view, imitate, replicate, and get on with your day. Running virtual machines in FreeBSD with vm-bhyve was requested several times in the comments. I've said it before, but I really do appreciate your interaction and discussion in the comments, so thank you very much for this. In this video, we're going to configure vm-bhyve, and we will spin up a FreeBSD virtual machine. I will call this a VM going forward, and a Linux VM. We will use Debian for this, but it can be easily adjusted, as you will see. We will install, set up, and configure vm-bhyve step by step with some tips and tricks along the way. This topic is not going to be for the faint of hearted, but if you like a good challenge, bear with me and I will try to make things as easy as possible for you. Now let's have a look at how well behaved vm-bhyve actually is. I'm starting out with a completely fresh installation of FreeBSD on a physical machine. If you need any help with getting started, there are links in the description of this video and in the FreeBSD playlist how to install X Windows, how to add a desktop manager like XFCE, GNOME, KDE or others, and how to configure Intel and/or NVIDIA graphics. I will follow a couple of defaults. This is just a place to start. Feel free to adjust anything to your liking. In case you didn't know yet, the vm-bhyve hypervisor is actually already on your system because it has been a part of the FreeBSD base system since version 10. vm-bhyve supports several guest operating systems, including of course FreeBSD itself, OpenBSD, many Linux distributions, and Microsoft Windows. By default, vm-bhyve provides access to a console, and it does not emulate a graphical console. This is of course possible, and you can connect to a graphical VM through VNC technology. For today, however, we're going to do everything from the terminal, so things can be scripted if you wish, and above all, this will provide a clear understanding of what is going on. In a follow-up video, we can certainly have a look at a remote connection to the graphical interface of an existing running VM. Although vm-bhyve itself is bundled with FreeBSD, we are actually going to use the vm-bhyve management system to manage the vm-bhyve virtual machines. As said before, all from the command line or terminal, but in my mind's eye, this video just serves as a base to get you started. From there, we can extend with more advanced VM options like snapshots, encrypting, GPU pass-through, advanced disk configurations, and maybe more. And also on top of vm-bhyve, you can add a graphical framework to administer and then manage your virtual machine infrastructure visually through a web interface. But first, let's check what we are working with. We are on FreeBSD 14.2 with the XFCE desktop environment. Next, we need to check if the system does support virtualization. Type the command tmesg pipe grep vt in capitals -x. This should return vt-x for Intel-based systems. Replace vt-x with AMD-v for AMD-based systems. My test system has an Intel processor, and in case of doubt, you can determine yours sysctl hw.model space hw.machine space hw.ncpu. Alternatively, you could also try tmesg pipe grep -i double quote vmx \pipe svm double quotes. Then check for vmx for Intel and svm for AMD. Just some of the many different ways to retrieve this information. By the way, if you like the pimped out terminal, there is once again a link in the description for your convenience. I'm going to assume that the machine you are using for this is not older than, let's say, 7 to 8 years. In that case, most likely virtualization settings are already enabled in your system's BIOS or UEFI, and as a result, it is now active in the operating system. Also, I am discussing this for a physical machine. The topic of running virtualization inside an existing VM, referred to as nested virtualization, is out of scope for this video. If in the output of the earlier commands vt-x or AMD-v are not displayed, go into your BIOS or UEFI and enable virtualization technology. This will be different for every machine, so you will have to do some research if needed. Once we know that the system is actually supporting virtualization, we can progress to the next step, Note that I'm performing everything while being logged on as a regular user by using sudo whenever I make a configuration change. Of course, you can just log in as root and then run it all from there. Now load the bhyve kernel module with the command kld load vmm. And if you want, double check if it's there with kld stat. To make sure the kernel module is loaded on every system boot, you can edit bootloader.conf. You can use any editor, but here I am demonstrating the easy editor. By adding the line vmm_load equals yes in capitals between quotes. Now we need to install some packages. Type the command sudo pkg install vm-bhyve bhyve-firmware. This will install the vm-bhyve management system, and just to have it ready, the bhyve firmware component is required to run UEFI-based virtual machines later down the road. To keep all VM images, ISO files, configuration and templates together, create a directory named VM. This will be referenced to as the dataset for your virtual machines. Sudo mkdir/vm. Of course, this directory will now be completely empty, but this will change soon enough. And to enable vm-bhyve when the system starts and to use the VM dataset, type sudo sysrc vm_enable equals yes in capitals between quotes, and sudo sysrc vm_dir equals /vm between quotes. You could verify if the new lines are there with cat/etc/rc.conf. Now populate the VM dataset with some required directories with the command vm-init. This will also load the kernel module, just in case we missed that earlier. The hidden directories .config, .img, .iso and .templates are now there. We will get back to each of them later on. When you create a virtual machine, you can use a templates file which defines the VM parameters, like the amount of memory, the number of CPU cores, and the disk configuration. In the .templates directory, there is currently only one template named default.conf. The default set of sample templates is located in the directory user local share examples vm-bhyve. Copy all of them to the VM dataset. Sudo cp, then the source directory, /**, and then /vm/.templates. They are now present in the vm.templates directory. There are several ways to connect a virtual machine to your host's network, and we are just going to be pragmatic here, and we will create a virtual switch with the name public and then attach the network interface to it. Check your network interfaces with ifconfig. And create the virtual switch named public. Sudo vm switch create public. And then attach your local network interface to it. Sudo vm switch add public re0. In my case, the local network interface is named re0. Just replace this with the name of your network interface. Check if the virtual switch is now added to the list ifconfig. Just pointing out that in case you make a mistake here, to clean up and start again, use the commands sudo vm switch destroy public and sudo vm switch remove public re0, or the name of your network interface. You administer bhyve via the vm command. We will check all of the available options later, but for now I would like to point out that you can check your virtual switch's details with sudo vm switch info public. Manage to bhyve via the vm commands. To get a feeling for all of the available options, type sudo vm-help. To check your version of the bhyve management system, type sudo vm-version. I've noticed there is a vm data store command, so let's try it to see where the vm data store is located. Sudo vm data store list. And indeed, it shows the /vm directory that we created and populated earlier as the VM data store. You can list all of your virtual machines with sudo vm list. And of course, at the moment, this list is empty. So it's time to add the first VM. All of the installation images or ISO files can be conveniently downloaded and kept in the .iso directory of the VM data store, all from the command line. This is not needed, they can be anywhere, and you can use any existing image files, but we are keeping it simple here. Let's assume that we don't have any .iso file yet, and we would like to install the latest version of FreeBSD at the time of recording of this video. The easiest way to get the download link is to simply visit FreeBSD's website, find the file you want, right-click and then copy the link. For this I'm going with the boot-only version, because then any needed files will be downloaded automatically during the installation. You can of course use the full version if you want, then adjust accordingly. To download this .iso and place it in the data store, type sudo vm iso and then paste the link. After the download, the installation image is now available in the .iso directory. To create the actual VM, type the command sudo vm create and then the name of your VM, in this case FreeBSD 142. And then check the VM list again, sudo vm list. By default, this will result in a VM with the name that you have specified with one CPU, 256 megabytes of memory, and of course it is now in a stopped state because it never started. We are yet to install the operating system. This hardware configuration is coming from the default.conf template file because we haven't specified otherwise. With sudo vm-help, we can see that there are several options available in the vm-create command to manually specify the hardware configuration or use a different template, etc. This way, you can certainly specify every configuration parameter in the command manually, but I just use to like the template file to keep things organized and structured. As such, the next step is to check out the template file. And there is the configuration of one CPU and 256 megabyte. So let's remove the existing VM and start again. You can remove a VM with the command sudo vm destroy and then the name. And if it was already in a stopped state, it should now be gone from the list. Now edit the template file to change this to your liking. I'm going with 1 gigabyte of memory. And I'm sure you have noticed that the template also contains the disk configuration. Create the VM again. By not specifying a template or anything else, it will use the default.conf template with a new configuration. Indeed, the VM now has 1 gigabyte of memory. To recap, we have the bhyve configuration in place, the ISO is there, the template was adjusted and the VM is there as well. The final step is to actually install the operating system and work with the VM. Type sudo vm install, then the name of your VM and the full path to the .iso file. By default, the VM will start in the background and then it will return the prompt to you. By using the -f option, you can start the VM directly in the foreground if that's what you want. but it is now running in the background as listed in the output of sudo vm list. To connect to a running virtual machine, let me open a new tab and type sudo vm console and then the name of the VM. It then reads connected, and all it needs now is just another hit on the enter key. And there it is, your new VM is waiting for your input to start the FreeBSD installer. If you need any help with installing FreeBSD, a detailed how-to video is linked in the description of this video for your convenience. I'm going to fast forward now and install FreeBSD. And eventually reboot the machine for its first boot. And there it is, FreeBSD running as a virtual machine or guest in a FreeBSD host system with bhyve. Let's power it off. To start it again, type sudo vm start and then the name of your VM. Again, without specifying the -f option, it will start in the background. Let's leave this VM running for now and continue with the second VM. If you skipped straight to this chapter, please be sure to check out the previous chapter for some necessary background information that is not repeated in this chapter. It is now the next day, and meanwhile I have stopped the first virtual machine as indicated in the output of VM list. Now it's time to install a second VM, this time Linux, and I will be using Debian. Of course, just adjust this to your Linux distribution of choice. Many Linux distros are using the grub bootloader, and to get this working we need just one more package. The package grub2-bhyve is required to run Linux or any other guests that need a grub bootloader. Install it with sudo pkg install grub2-bhyve. Just like before, let's check the template file, in this case the debian.conf file, and adjust. And get the download link to the ISO file, and we are going with the latest version of Debian as of the recording of this video. Now download the .iso and add it to the VM data store. Sudo vm iso and the link. Now there are two image files in the .iso directory. And create the VM, this time using the -t option to specify the Debian template. Remember that if omitted, it will use the default template. And the .s option to specify a virtual hard disk size of 50 GB. The name of the VM will be Debian. Sudo vm create -t Debian -s50g Debian. Once executed, there are now two VMs in the list. To start the Linux VM and the installation of Debian, type sudo vm install name of the VM and the path to your ISO. It started in the background. Connect to it using the vm console command. I'm going to fast forward now and install Debian, and I will deselect any desktop environment as I won't be needing them, and eventually reboot the machine for its first boot. While the installation is running, let me point out some useful VM commands. You can rename an existing VM, stop or start each VM individually, or stop and start them all at once. Reset, power off and destroy are also available, as well as the possibility of creating snapshots of your VMs. If you want to study each individual option, just check out the manual with the command man-vm. Remember that we edited the template files earlier instead of specifying all options manually. If you need to change the configuration of an existing VM later on, simply use the vm configure command to directly open the VM settings for editing. Sudo vm configure and then the name of your VM. The default editor will be the VI editor. Exit with escape, Q, ! Alternatively, you can directly edit the .conf file of your VM with your favorite editor as well. To get detailed information around the startup of the VM, you can check out the vm-bhyve log file for each machine. To double-check the size of the virtual disk, simply go into the VM's directory and then list the file sizes. disk0.img for the Debian VM is indeed 50 GB. After a system reboot, by default, all of your configured VMs will automatically start. If you don't want this, edit rc.conf, and by using the lines vm_list, you can specify manually the name of the VMs you want to be started. Handy if you have a lot of them. And with the line vm_delay, you can specify the startup delay if needed. Now back to the Debian VM. Debian is up and running. And after NeoFetch is installed, it reports that indeed we are running Debian under bhyve. At this point, vmlist now reports that there are 2 running virtual machines ready to serve as your future digital playground. That's it. Hope it helped, and if it did, please like the video and keep it up. Until next time, bye!